In this video, let's look at the average value of a function and then the units of the definite integral. So we know that the area under the curve is equal to the integral from a to b of f of x dx. And what this is saying is we're going to add up all those rectangles from a to b, and those rectangles have a height of f of x and a base of d of x. So if we have this function y equals f of x, and we know that the base is b minus a, I can find the average height. Let's see if I can grab my little blue line over here. Yep. I can say, is this the average height? Probably not. This would lead us to an underestimate of our area. Here, I think that would probably be an overestimate. So what we need to do is we need to use calculus to find that average height. And that would be somewhere probably right in here. So we can say that this total area, the sum of the areas of these rectangles, is equal to the average height times the base, right? And so if we wanted to solve for that average height and come up with some sort of equation, oops, sorry, that's way too big. F of x average would equal, well, let's multiply both sides by the reciprocal of b minus a. And this would be our formula that we're going to use. So whenever you see that coefficient of the integral, you're probably looking at an average value. All right, so here's our first example. I've placed my blue bar where I think the average value of this function is. All right, so let's use calculus to work through this one. All right, so let's see, 1 over b minus a, that's going to be 3 minus 1 of the integral from 1 to 3 of this function. And so let's see, that's going to be 1 over 2, and then the integral, the antiderivative of this would be x cubed over 3 plus x. And I'm going to evaluate that from 1 to 3. All right, so this is going to be 1/2, and if I substitute in a 3, 3 cubed is 27 over 3 is 9, plus 3 would give me 12. And then I'm going to subtract, if I substitute in 1 cubed is 1 over 3, so that's 1/3 plus 1, and so that would be 4/3. Okay, so I need a common denominator. So this would be, how about 36/3 minus 4/3? So that would give me 32/3, and half of 32/3 would be 32/6, which is about 5 and some change. Let's see, 1 and 2/6, so 5 1/3. And so that is pretty close to where I was estimating. My y-axis goes up to 10, so here's 5, and I'm a little bit more than 5. Let's try one more example. Again, I've placed my blue line where I think the average value is, and so let's use our calculus to figure out what that value is. So my integral this time is from -2 to 1, so 1 minus -2, and this is from -2 to 1 of this function. Okay, so this would give me 1/3, and then I need that antiderivative, so it'd be 1/2 x to the 4th over 4, x cubed over 3 plus x, and we're going to evaluate that from -2 to 1. All right, so we have a lot of little fraction work in here, so let's be patient. So I'm going to plug in 1. I have 1 to the 4th is 1/4 times 1/2, so that's going to give me 1/8. Plus 1/3, plus 1, and then minus, let's substitute in the 2, I'm sorry, the -2, so -2 to the 4th over 4, -2 cubed over 3, minus 2. And I need a common denominator, so in this first set of parentheses, that's going to be 24, and so that would be 3 24ths plus 8 24ths plus 24 24ths. And I think I need to clean up still a little bit more. So -2 to the 4th at 16/4 is 4, and half of that is 2. And then -2 cubed is -8. And let's see, I can eliminate this 2 and -2. And then in this first set of parentheses, let's go ahead and add those together. So 24 and 8's 32. 35/24, and then plus 8/3. One last fraction. I'm going to go ahead and use the common denominator of 24. So 3 goes in 8 times, so that's 64. 3 goes into 24 8 times. 8 times 8, 64. And so 99/24, which is, reduce the 3 and the 99, 33/24. So in a calculator, actually we can reduce that by 3, so that's 11/8. And 11/8 is 1 3/8, so a little less than 1 1/2, which is pretty much what I guessed here. This would be 1 2, and so that's right there. So it's not too bad, a little bit of fraction work. All right, so here's an AP question, and it's asking us, it says the rate of fuel consumption in gallons per minute recorded during an airplane flight is given by a twice differentiable and strictly increasing function r of time t. The graph of r and a table of selected values r of t for the time interval between 0 and 90 are shown above. Approximate the value of the integral from 0 to 90 of r of t dt using a left Riemann sum with 5 subintervals as indicated on the table. All right, so here's that first interval from 0 to 30, and then 30 to 40, 40 to 50, 50 to 70, and 70 to 90. So those are going to be my 5 rectangles. So from 0 to 30, 30 to 40, and this is a left Riemann sum, so it's the upper left-hand corner of our rectangles intersecting the curve. Here's our next one. So those are our 5 rectangles. If we were to find the areas of all of those, so this is for part C, base times height, so I would have 30 times 20 plus 10 times 30 plus 10 times 40 plus 20 times 55 plus 20 times 65. And if I added those up, that would give me my area. We can see that there are a lot of space right in here between the curve and those rectangles, so we know that this is going to be an underestimate. Because we have an increasing function with a left Riemann. All right, so that answers part C. And then for part D, between 0 and 90, explain the meaning of this interval, or this integral, in terms of fuel consumption for the plane. So now let's think about what each of these represent. R of T, that is gallons per minute. Oh, you know what? I'm not going to put it right there. I'm going to put it down here. Gallons per minute. And dt, that is minutes. So when we were multiplying these together, our minutes are going to cancel. That unit cancels, and we're left with just gallons. Now, our interval is from 0 to 90. So this is the amount in gallons of fuel that is consumed by this plane. And then this last one, this last part of the question is to explain this meeting. Well, 1 over b, well, that is finding the average value of this function. And so we could say that the average value of the function is the average rate of consumption in gallons that was used by this plane. So something like that. Let's take a look at one more. I've kind of whited out some of the portions because I just really want to focus on the average value. And so we have a test plane flies in a straight line with positive velocity in miles per minute at time t minutes where, and I can't see my thing, so I'm going to see if I can minimize this, where v is a differentiable function of t, selected values of v of t for a time between 0 and 40 are shown in the table above. Using the correct units, explain the meaning of the interval from 0 to 40 v of t in terms of the plane's flight. Okay, so v of t, that is measuring in miles per minute. And d is t is your minutes. And so our minutes are going to cancel. And so this is the miles traveled, or the distance traveled in miles between 0 for the first 40 minutes. So that's how we could answer it. So this is the miles traveled, or the total miles traveled, or the distance traveled in miles in the first 40 minutes. And then for part C, you're given this function, and this would be a calculator active function, so I'm not going to worry about doing anything with that. It just says, according to the model, what is the average velocity in miles per minute over this interval? And so the average velocity, if I wanted to figure that out, I would just have the interval from 1 over 40 minus 0 of the interval from 0 to 40 of f of t dt. And then, again, this is a calculator active. We'd plug it into our calculator and get this answer. All right, so now let's take a look at these units of the definite integral. It says if f of t is measured in meters per second and t is measured in seconds. So f of t, this is meters per second squared, and dt is seconds. We're going to have one of those seconds cancel, and so our final unit is going to be meters per second. And number 2, S of t is the rate of consumption of cola in the U.S. measured in billions of gallons per year, and t is measured in years since 1990. Interpret this. And so what this is saying, and an S of t, let's just think about this real quick. S of t is measured in gallons per year, and t is measured in years. And so when I multiply those, the product is going to give me just gallons. So this is going to be the total amount of cola consumed in gallons between, and it tells you time since 1990, between 1990 and 2000. That would be the 10 years. Okay, and in this one, this would give us the total amount of cola consumed in gallons. And okay, so if 1990 is year 0, year 13 would be 2003. And it ends at 14, so we're just looking at that 1 year. All right, number 3, it says WT is the rate at which a baby gains weight after birth, where W is measured in pounds per month and T is measured in months. So we have pounds per month times months. So we're looking at total pounds, and the time is measured in months. So we're only looking at the first month the baby is born, and it is normal to actually lose weight during that first month. And so that's what this one's saying. The total amount of weight that is lost during that first month is 0.127. This next interval from 0 to 12, so we're looking at the first year of life. So this is the total pounds gained over those first 12 months is 9.7 pounds. Okay, couple more. V of t is a function describing the volume of water in a canister measured in cubic inches, and t is measured in seconds. What does it mean to ask when V of t equals 0? Well, V of t is the volume of water. And so we're looking for when the volume of water is 0. So when is the canister empty? And so that's okay. And then what does it mean to ask when V prime of t? Well, that's the rate of change, when that rate of change is 0. So when is the volume not changing? And then here, we're looking at the first 20 seconds. During the first 20 seconds, we're looking at the total the sum of the change in the volume, because remember V of t is that change in volume. All right, last one, number 5. If F of t represents the rate of earnings of an individual born in 1965 in dollars and measured since 1965, so these are the first years. From 0 to age 13, you're earning nothing. That's correct. So the total earnings of a child in the first 13 years is 0, and it is reasonable. Here, we're looking at the first 40 years of your life. Could you earn $1 million? Yes, but perhaps not as a teacher. And the last one, this is your average amount of earnings of an individual over those first 40 years. So I hope you understand a little bit more about those units of the definite integral.